Okay, so it's a really packed summit. I was pleasantly surprised to see so many people. It's the first time, fun fact, after COVID, I actually presented on a live stage. My last one was many years ago on reInvent, so it's a good getting back in the game. So my name is Alex, with a last name you cannot pronounce, so don't try. I'm leading infrastructure group at a company called City Storage Systems. We're also known as CloudKitchens's. We're a stealth startup, and we'll talk a little bit about what we do. And then you can think about me as a dark side of engineering. I'm a manager now. I've been with the company for a long time. All the mistakes are mine. Everything you see, you disagree, that's my fault. And then Ammar will be talking about how we're fixing all the problems. So everything good you hear, that's him. Let's go. So CSS, startup in a food space. What we're trying to do, we're trying to make on-demand food affordable. That's pretty much the mission statement. And we operate facility, we call it facility delivery only kitchens all over the world. We have SaaS stack, Try Picnic is an interesting new thing, which is not available everywhere, but you may want to check it out. And TLDR, we're right now in the process of moving to Ray. We're pretty much trying to move to Ray all our machine learning infra, and even possibly data infrastructure, which I think is interesting. I represent internal infra team, which manages all infra for the company, observability, compute, storage, all of it, and ML. And Ammar is coming from actual machine learning group. All right, gonna talk about ML platform, the first attempt, a little bit about why we decided to rebuild, what principles we used, and actually Ammar gonna give you interesting details of how we're doing it. First attempt. So, 5 years of a fairly small team, and then I'm just gonna show you our tech stack and how it evolved. We started with Google Cloud, heavy Kubernetes users. By heavy, I mean we don't run anything outside of Kubernetes. Very philosophical means we spent months of arguing and debating what's an operator and how to do things. But as an end result, we got really good at it. Trino is our main data warehouse, Hudi our storage format, superset there just because we use it for data visualizations still. Later, we added notebooks like everybody else. The M stands for monorepo. It's not specific to any vendor, but we went really early with monorepo. We added Bazel, which we later removed for Python because it was painful. I do not recommend if any of you thinking about it. Selden for serving and Flink for idea behind Flink was to complement Trino. As you noticed, we added batch capabilities only on year 3, actually, of company existence, because we were very into real-time stack, and we were trying to avoid batch systems like Apache Spark actively, actually. Even though you see Spark on a slide, as an infra, we never officially supported it. Right, because it's a data scientist, Garrett presented yesterday. It's a DS team who really wanted it, so they ran it. They piggybacked on some other pieces of infra, but we never supported it. Argo for orchestration. We love YAML. Data scientists don't, so we built on transpiler using Kubeflow pipelines, so you can write Python, which gets translated into YAML, because turns out nobody can understand YAML. Custom-made feature store, like Streamlit, NVIDIA, like GPUs arrived in 2022, but the year 2022 was dominated by moving to Azure. So there's not much things going on machine learning. And in 2023, we realized we need to make changes, mostly because 2022 was a lot of infra low-level migration work. And we tried to explore Kubeflow, Polyaxon, Hopsworks, and Ray. So you see, we failed in deploying Kubeflow, Polyaxon, and Hopsworks. This is not fault of those technologies. It's incompatibility with how we do. As I mentioned, we started Kube really early. We did it our own way. There's like interesting details, which I'm not going to cover today. But it makes it really hard to deploy just open source projects, or sometimes like vendor projects. And Ray was the one that actually survived. And then this year, oops, that was weird. Anyway, and then this year, we doubled down on Ray. We brought a thing called Daft. Metaflow, Poetry, Iceberg showed up in a stack. And we are actively trying to kill all old systems. Now, it's actually okay. Like as an infra teams, we don't have to maintain like old mistakes or systems that we thought was a good idea and turned out not to be. So I see it as a very positive sign. Now there's two controversies on here. What we would like to also possibly remove are those two things, Trino and Flink. And the reason is if Ray can do everything, why run additional systems? Now, it can't at the moment, but there's an idea that it may in the future. What's our vision for the platform? Or let's say, what's our dream? So the dream is we are not ML company. What I mean is we don't do machine learning for the sake of machine learning. We do machine learning to help business. So there's a lot of text, but TLDR is I believe everybody should be doing machine learning, even if it's not perfect, like this specific slide or this specific writing. And the thinking, there's presentations I've seen talking about MLOps, DataOps, MLOps, I know data. I think machine learning will be a competency of an engineer, same as QA, same as running systems in production like DevOps. I feel it's inevitable. And the focus should be on making sure infrastructure can support people who are coming from those engineering backgrounds so they can utilize ML, and also actually non-engineers. Why rebuild? Simple, less is actually way more. It's my dark side perspective, guys. Three things are important for development. One, time to done. So we exist because CEOs need stuff to get done, right? Like if you think about it. And they want stuff to be done really, really fast. If it takes longer to do stuff, our value decreases, right? So if you think about it, the platform, the systems, the infra, wherever it's called, should razor focus on how to accelerate, how to give velocity to people who actually get things done. It's less important what's right. Is it like okay to deploy notebook to prod, or is it not okay? It's more about how do we create value as fast as possible, especially for startups. Another thing, it should be fun, because if it's not fun, if it's hard, less things will get done. And third one, I call it big O of a real life, it's money, right? Wherever is running should be cost efficient. If it's not cost efficient, it doesn't matter. Doesn't matter because we just burn in cash, and at some point you run out of cash, right? So those principles, we took them and looked at our infra, and then here's what we've seen. There was too many moving parts. There was high friction because we had some theoretical statements, right? To deploy, you must go through our release pipeline, which was monorepo based, was taking time. You must be like a software engineer. You must know Docker. PhD in infra needed. We taught data scientists really, really early what Docker is. I still remember a couple PhDs were coming and like, how do I deploy a model? Like, well, you start with this page about Docker, and here's Kubernetes, and then here's YAML and CRDs. And then we took all of it and said, okay, so what can we do better? And we said, let's focus on velocity. That's where our value is. Cohesion, because it helps with velocity. We were unopinionated before. We said we will be more opinionated. We'll provide some tools, and we'll weed out tools which we think are not good, so we're going to limit choices. We will try to make simple things very, very easy, and hard things will be possible. And we'll take some risks. So some of the pieces you probably never heard of, like Daft. What is Daft? Metaflow, there's going to be talk right after. I think it's system from Netflix. And then we pick them for the only one reason, We believe that they just making data science flow, ML flow, very simple, enjoyable, and an idea is they work faster, they find more interesting projects, we can productionize later, right? That's infra land. And stuff which we will keep, auto-scaling, all of this given infrastructure, buzzwords, they still stay, right? That's, again, job of infra teams to make sure infrastructure is invisible. But at least it's not, this idea that should not be getting into a way. So with all set, I'm giving it to Ammar, who's going to walk you through actual implementation. Thank you, guys.
All right. So today I'm going to talk about our machine learning platform. I'm going to start with what it is, basically. I'll try to go over overview, and then we're going to talk about how we got Ray infrastructure working in CloudKitchens. And then we'll talk about about a couple of topics, maybe data preparation specifically, because we had some trouble there, and also how once you get the tools, how does it look like to the actual user who are going to use all of these things? How do we glue it all together, basically? So internally, we call it the dream stack. Unfortunately, poetry doesn't start with an E. Otherwise, it would be actually very cool. Yeah. So, okay, here's our overview of our tools. Basically, we start with the infrastructure. Infrastructure, like Alex said, we are like a Kubernetes kitchen shop, so nothing changed there. And then and the next thing is maybe I'll talk about the services. Like in Argo is a workflow engine. It is used if you want to have a durable way to run your pipelines that have multiple steps. Ray, I will assume everybody knows what Ray is. Metaflow is a framework for DSML to run their pipelines. I will go over them quickly, but during the presentation, I'll reintroduce them again, so you don't have to really remember everything. Daft is going to be our data frame API of choice that we support. We'll talk about that later. Poetry, our build system. So we used to work with Bazel, and then we had a lot of trouble getting Bazel to work with Python, and then we had to actually go to another build system, which is Poetry. It's better than Bazel. If you try to go with Bazel for Python, maybe reconsider. That's my there. All right. So what it is, we wanted to talk about first why we chose Ray. The first thing, it's Python native, Pythonic APIs. Good thing about it is that you don't have to worry about these stack traces. If you're Python native and you come from Python land and you see the stack trace and there's some Java, Lang, Spark, something is wrong, you don't know what to do. So and also if you have jars or there's a jar missing or something, that's probably not a good thing to see. Next is our unified. It's because it has unified compute layer. You basically have your data prep, you have your training, your serving, all using the same code. That's actually pretty impressive. The way we used to do before, every stage has its own tools, its own libraries, and they are very different, and you have to context switch to go to the next one. And also, it has the potential can be used for streaming. Stream processing, reducing infra footprint, like what Alex mentioned before. There is also seamless integration with third party. That's pretty impressive. High performance and scalability, I guess, as we know here. And you can do LLMs, has the ability to run LLMs as well, if we ever need to do that in the future. Right now, we're kind of using LLM, but not actually creating LLMs or running LLMs on our infrastructure. All right. So next, we're going to talk about the Ray infrastructure. So we use Ray. It's our choice for running Ray locally. If you're running on Kubernetes, it's the default actually choice to run. And for people who don't know, Ray is like a Kubernetes operator for Ray to get like being able to deploy your Ray clusters using it. All right. Okay, so one problem, or not problem, it's outside of Ray, we wanted to have like extra functionalities on top. First thing, we wanted to hide the YAML. We don't want people actually to work with YAMLs and change them and edit them all the time. Like Alex mentioned, we had like people, we have a Kubernetes cluster. If you expose all of that a lot, it's actually very hard for the user to actually understand what's going on. There's a lot of low-level details. We wanted also like to have like a simple way for CRUDL, for clusters as well. We wanted to isolate clusters for teams working together to collaborate on data. And there's like, we wanted also to get like the multi-regional so we can go where the compute is. Sometimes the region we have is doesn't have GPUs that we want, so we want clusters in those other other clusters, for example. Our ultimate goal is users submit Python code and it works, so they don't really have to worry about their like where is the infrastructure, where is the Ray address, how many, I guess, GPUs, or this is like the ultimate goal we want to, is like, okay, give me your code, we'll try to run it for you. But that's actually very hard to do, so we are actually trying to get to that point. And a solution to get started on that route is actually to build a Ray control plane that handles management and cluster isolation to start. So what I'm going to show here is our Ray control plane. The control plane is a service that Ray operator or user can interact with to create, update, delete clusters. It has the capability to create clusters in different regions, as I mentioned. It also simplifies the configuration management between clusters by having like a master template, and you use that to create clusters. And if any cluster needs something special, you can just change that, and that is the only thing that is needed. And it makes it easy to actually deploy, update, and delete all of that. All right. So obviously, whenever you show like the control plane, here's the data plane. The data plane has like interesting design. We actually have a Ray proxy that handles authentication, authorization, and routes users to the correct cluster, right? So they don't actually give us the real Ray address. They give us like a URL, and it has like the project, the team, and so on, and then we route them to the right Ray cluster for them. This allows us to abstract the address of the Ray cluster, and later we can have like ephemeral or serverless design if we want to later, because they're just interacting with the proxy. All right, so next up, I'm going to talk about the data preparation. So in general, we are betting that Ray can do everything, like streaming, batch, everything, and only use Ray for our like data preparation and ETL, like without using Spark. So for that, we have two tools that help us here. So Daft is our data frame API of choice. Chino is our data warehouse SQL engine to get the data working from the data warehouse to read it. And like hopefully together, we'll get most of the data preparation and processing working. So let's go, okay. I wanted to maybe talk a little bit more about Daft. It's an open source project. You can actually have like, you can just run pip install git Daft there, and actually you can run it locally. That's actually pretty good. And once you get that running, you can actually also run your data frames on Ray clusters. If you give it, if you run Daft in a data Ray a data cluster. It has like distributed job execution. It's Rust and has multi-node parallelism, active community. It's expanding. Everybody is responsive, and that's very impressive. And also, it's built on Apache Arrow, so you can actually, if you're using Ray data, you can actually easily move the data around between Daft and Ray data and other ones that have Apache Arrow. If you are interested in more details about it, actually, we had a talk yesterday given by Garrett from our team, talking in details about how Daft work inside CloudKitchens. So maybe if you haven't seen that, maybe you can watch the video when it airs. And also there's another talk by Jay from Eventual, the team behind Daft, about like how to use Daft and unlocking ETL basically. All right. So the last thing I'm gonna talk about is gluing it all together. Because we have a bunch of tools, we need to get them all working together. So let's look at how we did it. So we use some an open source project called Metaflow that actually you can run your code in Python, and that's designed to get like the data scientists, machine learning engineers just to use that. And you can run locally, you can debug and make sure that everything working fine. And once you're ready, you can actually run it on Argo. Argo is our workflow engine that you can run it on Kubernetes, basically. This example is very simple. So as you can see, the first step is basically you just get a list of numbers, 1 to 10. That's basically, and then the next step is you just sum the numbers, and the third step is just print it. So, and each one is a step by itself. So that's how Metaflow works. However, in Metaflow, there wasn't an out-of-box way to run Ray code. So we decided to write a plugin on Metaflow to do that. So let's see how we can convert this kind of code to use that, basically. So let's look maybe at the first step. We have a Ray. We have like the step for the decorator that designates that Metaflow step as a Ray step. What this will do is that it will submit the code written there as Ray job. Also, you can see Daft running in action, where we just read the numbers and do a summation on it, basically. Also, at the top of the file, you can see that also made a Poetry plugin on Metaflow. So our users can also handle like third-party and first-party dependencies from Poetry rather than use the Metaflow out of the box. The way Metaflow has it is kind of different, and we have it. We have our dependencies using Poetry, so we use that to get that working. All right. Okay. Maybe I'll talk a bit about like how these work. Ray step packaging. The plugin actually downloads the Metaflow code package tarball, extract to a temp directory, and do Ray submit. The decorator also runs the decorator function in a Ray job so that it respects that it's actually running on Metaflow. For Poetry plugin, it reads actually the Pi project YAML and the Poetry lock to actually get those dependencies, and then it uses the Metaflow way to add those dependencies, basically. And for the user, if they add just that, it will actually work for them. I think that's all. So if you have any questions, yeah, please ask. Yeah. Yeah, sure.
So you showed us the Ray step, which is the integration you built between Metaflow and Ray. I'm assuming there is no other integration that exists.
You mean out of the box, you mean? Or?
Nobody has built an integration between Metaflow and Ray before.
I think actually right after this, there's Autodesk, and they have a plugin also to do that. I think we had like the time to look at that, but we decided to do a different one. There was like differences in maybe how it's done on their side, but it's actually right after this in the lightning talk after. So it's actually pretty interesting if you want to go and see that as well. Yeah.
Have you open sourced it?
No, it's not open source yet. Yeah.
You mentioned that you just have a proxy for like when users submit job and post their proxy and then like you don't have to worry about the cluster it's going to. So are you guys deciding right now like where to put jobs? Are you doing like job cluster or cluster per team or everything to one cluster?
Yeah. So right now we have a domain where like that the team and a project. And in your URL, actually, you have to write them down because you can work on multiple projects or things like that. But that's like just the starting design to get this working first, and then later we'll add more for like ephemerals. For example, you can write /ephemeral, for example, and then it will actually create a new cluster for you and then run that for you. That can be something that we can do in the future. But right now, it's actually just standing clusters that gets routed to it, basically. Yeah.
I'm a little bit curious about the Ray data and Daft interaction, how you guys kind of interface with that. Is it that both tools, like you need specific functionality from like the tools individually that you can't find in the other? Or yeah, how do the two basically interact in your stack?
Yeah, so I guess maybe I'll talk a little bit about the choice. So we like looked into Ray data, and when we actually gave it to our users, they had questions about, okay, how can I do a join? Oh, I want this function, I want that function. And like at the time, we didn't know, we were wondering what's going on. Then we found Daft, and it actually did all these operations. And also we had like another issue with, I remember like Ray data, it wasn't performing as we wanted. And that's where also Daft actually helped us to steer us into that direction. Did I answer your question? Yeah.
I'll also chime in. It's actually unclear right now whether Anyscale interested in doubling down on Ray data for some obvious reasons. And we really want to reduce our tech stack, right? Like I said, we're trying to eliminate Apache Spark, right, from the stack completely. By shifting workloads that Apache Spark may run or Trino may run into Ray, it's not necessarily uncontroversial opinion, let's put it that way. And Daft, for example, I believe creator of Ray data is now at Daft, a company called Eventual. Yeah. So that's an answer. So there's another note on clusters. We followed same design principle we used for Trino. There's gateway, which is smart, and then it just gives us entry point where we can put our code. Right, so we're just like pretty much doing the same thing. We say Trino, we built almost like internal Athena, AWS Athena, when you just throw a SQL query and then magic happens. Users don't see it, don't manage clusters. If you ask us why we did it, costs, right, will be the answer. We are significantly cheaper infra plus people than, like Athena, BigQuery, like, Snowflake. So, all right, go ahead.
Frameworks like Dask. Why did you choose that?
Yeah, did we look at other data frames? Yes, yeah, we did like extensive research internally. I think like anecdotally, like last Ray Summit, there was a very interesting presentation by AWS guys, how they use Daft to reduce S3 costs for compactions. And Daft is a very young project, very, very young project. But the team behind is pretty strong, and that's like we have this culture of taking big bold bets, in a company, I consider it that wild bet. If it's successful and its looking trajectory is good, we're gonna get ourselves in a pretty good spot, right, with a vibrant community moving really fast. Many data systems right now are implemented in Rust. It's like a trend right now. New database comes online, you're like, what's the programming language? Rust. Right, and then that kind of fits the bill as well. And then those are reasons, not, and then performance also was satisfactory, but it's a bet. We bet in that they can pull it off.
I think we're
How
out
do
of
you,
time.
how do you handle scaling, given a piece of code that a user submits? How do you let them run it? How does auto scale? What's an acceptable runtime?
We're using, I mean, we're not doing anything like super smart right now, right? For the scaling of a specific job, we outsource into the operator. Right, control plane manages operator in a way, and then as I said before, that's actually a new pattern in a company because we have some multi-regional operators which manage other multi-regional operators, like Cockroach is a good example of it. But in this case, we decided to do something slightly different, have a separate control plane, which is not operator. It's actual software which runs on top of distributed database and can like figure out where to submit. And then once it's submit, then the local in-cluster responsibility goes to operator.
All right, I guess we're out of time, actually.
Yeah. All right. No more questions. We'll be hanging around if you guys want to stop by and ask more questions. But thank you for attending.